Okay, sorry for the interrupting. Akshata Madiwal, can you please join here instead of presenting? Present ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ ಜಸ್ಟ್ ಏನಪ್ಪ ಅಂದರೆ ಜಾಯ್ನ್ ಆಗರಷ್ಟೇ ಮತ್ತೇನೂ ಇಲ್ಲ. Okay. Okay, so right now just to look at here we will go with the concept. Okay, so hope that are able to visible this picture, all of you. Okay, so right now just I will go with the previous class what we have discussed there. In the previous class just we discussed what is this current electricity and what is this Biot-Savart's law and what is the unit and what are the basic rules here, swimming rule and screw rule, and there is under right hand clasp rule and okay, those are three basic rules we have discussed, and moreover just we have discussed the important Laplace of Biot-Savart's law or rule, and with respect to that just we got the derivation regarding that Biot-Savart's law. So that is finally, as I said that in the previous class, dB is equals to mu naught by 4 pi into ideal sine theta by r square. This is what the final expression what we got it in the previous class. Okay, so let it these things, and we will go with the next concept, important concept. Okay, so now, so right now just all of you last I'll again I'll confirm once again, are you able to audible and are you able to visual this slide? If anybody, any one of you, unmute your audio and let me know here.
Yes, sir.
Okay, so now so in this class the very important concept that is what you are having here, magnetic field due to a straight current carrying a conductor of a finite length. This is what your important concept, and we need to discuss on this concept, and it's a very important for your exams also. Okay, and now here this concept which is related with the previous basic law or else rule, that is what the Biot-Savart's law. Okay, so hope that if you know that the previous one means it will be very easier to you. Okay, and right now just to look at this title what it will gives you here, the magnetic field due to a straight current carrying a conductor of a finite length. Here if you are consider any kind of conductor which is having a length, it is having the finite length. I had considered the 5 centimeter or the 10 centimeter, whatever it may be, it should be in the finite length. Okay, so right now just I need to consider here, I need to find it here how much the current is passing through this and how much the magnetic field is carrying through this current carrying a conductor, just we are going to derive here. Okay, and right now just to look at here this figure, it's a very important thing, you will get it very easily. Okay, so now here just to see the arrow mark very carefully. Right now I had considered the one conductor that is from A to B, it is having the, as I said, that it is the finite length. Okay, so what is the length here you are having? A to B is there. Okay, suppose if I had considered the straight conductor carrying a current of I, current we know that we can notate and we can give a symbol of current is I here, and here just I had considered the current carrying conductor, it is the length is about AB. Okay, and here the magnetic field intensity is to be determined at a point P. The very simple thing is what, as I had considered here, I need to find it here the how much the magnetic field is with respect to this current carrying a conductor, and right now here I am going to determine at the point P. Just to look at this arrow mark, I had mentioned here P is the point. Okay, this is far away from this AB. This is what the state conductor carrying a current of I here. I need to determine the magnetic field intensity at this point P. Okay, and now see here before going to the next step, I'll discuss this figure what that will shows you here. Okay, here this is A to B, this is the length of conductor, and this is I is what the current carrying conductor. Okay, and just to look at here, this is the these are the very important thing, and another thing is what this point P, what that will shows you, what that will gives you the magnetic field intensity. I am going to determine the magnetic field intensity at the point P here. Okay, so with respect to these three phenomena, I will get the remaining other parameters also. Okay, just to look at here, these dotted lines and these dotted lines BP and AP, what that will shows you, that will shows you like, just to look at here, it will shows you a triangle, right? And now look at here, I will consider only the small element from this current carrying a conductor. Okay, I should not go with the complete whole conductor. I will consider only this length only. Just to look at here, E and F, I had taken only the small length. Is that right? The whole length is what? L. Is that right? And now here, what is the small length here I had considered? DL. Why I had considered here? I had considered a very small length. Due to that reason, just I had considered this one as the a small element of length, that is dl. Okay, and now I had considered the this point P from here to here, PF and PE. With respect to that, the making an angle pi, and from here to here pi 2, and from the downwards pi 1, and this is what the how much the radius from current carrying conductor to the point P, that is the capital R. Okay, just a moment.
Excuse me, sir.
Huh?
Sir, PPT consult.
Kanasila?
No, sir.
Okay, so you should have to tell now. Okay, that's okay. Just a moment. I'll check it once again. Okay. So now is that visible? Kansatana ivaga?
Yes, sir.
Okay. So just a moment. I will maximize this one. Let me know. Okay. Now are you able to see this slide?
Yes, sir.
Okay. So now ಮುತ್ತಿಷ್ಟೊತ್ತನಕ ಗಪ್ಪ ಅದಿರಲ್ರ ಎಲ್ರು. So everything should be based on this picture only, figure only, no? So you should have to tell. Okay. So now, are you able to see this figure, all of you? Okay. So see here, if you are
Yes,
not
sir.
if you are not able to visualize means let me know here. Okay. So okay, so right now just look at here. What I said that this is A to B is the length of the conductor. Okay, and DL is the small element, just what we had chosen here, that is the DL. Okay, I had given the points as E and F here. Okay, current just I had mentioned this one as the I. Okay, and this is R, capital R. What that will shows you? That will shows you the distance between the current carrying a conductor and the magnetic field intensity is to be determined at the point P. Okay, and now here, uh, okay, somebody wants to join here again. Okay, now here what we are having here the angle I had considered here, the general angle, this is what the pi. Okay, and here this is the due to the small element, length element, due to that reason just I had considered instead of pi, just I had considered d pi. Okay, and now here pi 1 and pi 2, why I had taken this is pi 1 and pi 2, this is just I had considered half of the portion of this current carrying a conductor, that is qa for a pi 1 angle, and for a this bpq, this is pi 2. Okay, and now here with respect to that, here I had considered the another angle. Just to look at here, this is what the theta, that will shows you the triangle, that is qpe. Okay, for this just I had considered this is the theta, and small r, what that will shows you, that is the vector position from point P to the E here. Okay, and now here everything should be based on dependent on this figure. Okay, you should have to know this one. Okay, okay, and now I'll go with the next slide. Here, according to the Biot-Savart's law, the magnetic field at point P, and remember, will you remember the Biot-Savart's law equation what we are having? Will you remember this one? Delta b. Okay, in the previous class just I said that instead of dphi, just I derived that one as a delta b. You may take that one as a db also. Okay, don't get confused. Okay, now here what we are having, db, that is db is equals to what we are having, we can consider this one as the k, or else you can write this one as a mu naught by 4 pi into are you able to see the slide here? Next slide. Next
Yes, sir.
ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ? Okay, so now our dB is equals to what we are having, mu naught by 4 pi into ideal sine theta, okay, whole divided by r square. Okay, so hope that you remember that in the previous and in the previous class we derived this one already, is that right? So right now by using that equation only, just we are going to get this expression regarding this magnetic field due to a straight current carrying conductor of a finite length. Okay, and now see here in this picture what we are having, whatever you are having this triangles, just I will take that portion only, that is the very important thing for us. Okay, so due to that reason just I had considered that one only. Okay, so now here just to look at here e z, just to see it, just to look at this arrow mark. Okay, you will get it very easily. Ez is equals to, hope that you know that the trigonometric functions. Okay, hypotenuse and opposite and all the things all of you know already. Okay, those are the basic important formulas, just you need to know that one, where that I can write by using this triangle. Ez is equals to, how can I write this one, ef into sine theta. Okay, and now I can rewrite this one as ಏನಾಯ್ತು. Okay, so now see here, uh, what we are having is equals to ef sine theta, and already what we know here, from e to f we had considered the small length. What we are having here, we are having dl, right? Wait a moment. So now here uh, we can take this ef is equals to dl, where that I got here is equals to dl sine theta. Okay, and now in the similar way I can rewrite this ez is equals to ep sine d phi, where that what we are having, due to this small part of this current carrying conductor, I had considered this one as the sine d pi. Okay, and now here what we are having here, here ef I had considered one length, and here from this ep, so that's why I can consider ez is equals to ep sine d phi. So now ep is equals to what we are having, what is the length from e to p here, here r is there. Okay, so now due to that reason ep can be replaced by r, so due to that reason ez is equals to how much we got here, r
R sine theta.
r sine d pi. Okay, now ez is equals to, we can rewrite this one as the r d pi. May I know that where is the sign? Simply the thing is what, hope that this thing is everywhere in the mathematical treatment, hope that you will remember that what we will take means at the certain time we are going to negotiate the sine thing here, because sine theta is very less than, or else which is almost equals to, what it will be equivalent to what, d theta. So in the similar way here ez is equals to, I can rewrite this one as the r d pi. Okay, so now what we got, we got the two expression from this uh, uh, epz and ezf, two triangles. Okay, so now I can write it here, just to equate these two equations. This is ez is equals to dl sine theta is there, and ez is equals to r d pi. So right now ಎರಡು equate ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, so simply what we will get, dl sine theta is equals to r d pi. Okay, I understood this one.
Yes, sir.
Okay, okay, your friends are going to enter here. Okay, so now here we got this equation. Okay, so now finally already we know that the Biot-Savart's law equation, is that right? What we are having the Biot-Savart's law equation, that equation is having dB is equals to mu naught by 4 phi idl sin theta by r square. Okay, so now dl sin theta is equals to ನಮ್ಗೆ ಏನು ಬಂದಿದೆ ಇಲ್ಲಿ r d pi, right? Simply will you substitute here dl sin theta is equals to, just look at this arrow mark, simply I will substitute r d pi here.
D5.
So what we got it here, dB is equals to mu naught by 4 pi, here r square is there, so r get cancels, you are remaining with I d pi by r here. Okay, I got this expression finally after substituting this. So now dB is equals to, finally we got mu naught by 4 pi into I d pi r. Okay, and now see here, so okay, we got this equation, and just we had given this equation as a 3, and now just to look at here, just I had considered the another triangle, that is EQP, the same picture already we are having this one, right? So now from this triangle I am going to define this r vector r, small r. Okay, so hope that from this r I can define this one as the r small r is equals to r divided by cos pi. Instead of this, I can consider this one as capital R is equals to, what we can write this one as the r cos pi.
Into cos.
Okay, now what I will do simply, so in the previous equation what we are having here, small r is there, is that right? So now simply substitute small r in the previous equation. Okay, so in the previous equation if you substitute that one, means what you will get it here, dB is equals to mu naught by 4 phi, okay, into small r the another capital R, and again the cos pi will goes to the numerator, okay, into d pi. Okay, so now have you got this one here? This is what, remember all of you, I can tell you this dB is equals to mu naught by 4 phi into I cos pi d phi whole divided by r. This is the final expression for this concept. But the thing is what, here just what I had considered, am I considered the whole conductor, or else I had considered the only small element of that conductor? Simply I had considered only small element. Is that right? DL. Only ಏನಪ್ಪಾ andre I had considered the small element of that conductor. So right now finally what I have to get here, I need to get here complete total magnetic field. I have to get it here. So due to that reason what I have to do here, then the total magnetic field at a point P due to the entire conductor is, okay, so ಏನಪ್ಪಾ ಅಂದ್ರೆ ನಾನು ಈ ಸ್ಮಾಲ್ ಪೋರ್ಷನ್ ನ ಮಾತ್ರ ನಾನು ಈಗ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಡಿಟರ್ಮೈನ್ ಮಾಡಿದೆ. But the question is what, I need to get the entire conductor. Okay, I need to find the total magnetic field. Okay, so due to that reason ನೀವೇನಪ್ಪಾ ಅಂತಂದ್ರೆ, if you want to find the entire conductor of an magnetic field, means total magnetic field, means what you have to do here, just simply just use the mathematical treatment here. Simply just you need to take the integration. Understood all of you? So right now, so hope that you know the applications of differentiation and the integration. Okay, if you want to take a very small part, means just you are going to apply the differentiation, and right now if you want to find the whole thing, complete portion, means you are going to use the integration. This is a very beautiful application of this integration and the differentiation. Okay, so now what I will do, I'll consider the entire conductor, and I need to find the magnetic field, that is what the dB. I can consider here B here because I need the total magnetic field here. So now B is equals to, what I will consider here, what is the limit here, minus pi 1 to the pi 2. Is that right? So right now here if I had considered the lower portion and the upper portion, means here as we had considered the lower portion as up to the negative point, that is what the minus pi 1 to the pi 2, and into what we are having here, mu naught by 4 pi I by r into cos pi d pi. Okay, and now simply the very simple thing is that simply take it outside the constant things. What are the constant things you are having here? Mu naught by 4 phi into I by r. This is what the constant thing. Okay, and right now you are remaining with what? Cos pi d phi. What is the integration of cos pi? So all of you know here simply sine phi. Okay, what is the limit here you are having? Minus pi 1 to the phi 2. Okay, and now simply substitute the limit here what we are having. Simply we can get it here. Sine pi 2 plus sine pi 1, or else sine pi 1 plus sine phi 2, because according to this limit substitution what we are having, what we'll get it here? Sine pi 2 minus sine pi 1, because what we are having, so minus pi 1 is there already, minus into minus, that will give you a plus. So due to that reason, final total magnetic field at a point p due to the entire conductor b, we can write that one as the final expression, that is mu naught by 4 pi into I by r, and into the bracket sine pi 1 plus sine pi 2. This is what the final expression of the total magnetic field to the entire conductor. And it's a very very important, and remember all of you, based on this one you are having the problems also. Just you need to remember these formulas, these are the very important thing. And moreover, if you know the Biot-Savart's law, means it will be easier to get the total magnetic field to the straight current carrying a conductor. It is a very easier to you. Okay, all of you got this expression. B is equals to mu naught I by 4 pi r into the sine pi 1 plus pi 2. Okay, so understood all of you. So this is what the final expression. Okay, and now in this expression, it's a very important, we will get the cases here. How we will get the cases means, simply just to look at here. Now what I will consider, if I had considered here for any conductor of infinite length. Okay, so ಯಾರದು ಮ್ಯೂಟ್ ಮಾಡ್ರಿ ಅದನ್ನ, just mute your audio. Okay, for any conductor of infinite length. So right now whatever we have looked at here. Okay, so now here whatever we have looked at here, are you able to see this slide? For
Yes,
any
sir.
conductor of infinite length, what we are having here ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ, I will consider the angle as a 90 degree. Okay, so pi 1 is 90 degree and pi 2 is also 90 degree. So can you just tell me that sine 90 is how much? Anyone of you?
One, sir.
Okay, good. Sine 0 is 0, sine 90 is 1, simply. Okay, so right now what we are having, sine pi 1 plus sine pi 2 is there. So 1 plus 1, 2 simply. And finally, we will get the, for the infinite length of this conductor, I can write the final expression as B is equals to mu naught by 4 pi to I by R. Okay, this is what the final expression towards the any conductor of infinite length. And here this is what, this is any conductor of the finite length. Here we got the two cases, remember all of you, don't get confused. Okay, even though in the exam they will ask for the both the cases, they may ask the 5 plus 5 marks. It's a very simple thing. Okay, and it's a very tricky also. So now here, what is the unit of this one? Newton per ampere per meter. This is what the unit of this magnetic field, total magnetic field with infinite length. Okay, so now these are the two very important expressions, and you need to know these two expressions. Okay, and now here, remember all of you, just I will make a little bit, I will make the some elaboration towards these two concepts. Simply the thing is what, the direction of the magnetic field due to a current carrying a conductor can be obtained using any of the laws, like, simply the thing is what, already we have discussed in the Biot-Savart's law. Okay, so what are Biot-Savart's law ನಲ್ಲಿ ನಾವು ಏನಪ್ಪಾ ಅಂದ್ರೆ three laws just we have used that one. Okay, uh, we have used all those laws the similar way, just the same thing only here, right hand palm rule, and right hand thumb rule, and Maxwell right hand screw rule. Already we have discussed these rules already in the while discussing in the bioshower slide itself. These are the very basic things. Okay, what that will shows. For example, if I had considered here. Okay, so right now already we have discussed this one. Simply just once again, just I am going to show you simply what that will shows you. Simply these are the magnetic fields which is surrounded by this current carrying a conductor, and this thumb what that will shows you, that will shows you in this direction the magnetic field and the current is carrying towards this current this conductor. Okay, these are the what the these basic three laws will explains to us. Okay, so right now just you need to know that one what are the basic laws. Okay, but before that just we need to make a concentration towards this uh, these two. One is a length, finite length, and another one is the infinite length. Okay, these are the very important expression, and even though moreover not only for the theoretical part, and it's a very important for the problematic also. Okay, if you remember these two formulas means it will be easier to solve the problems. Okay, simply the thing is what they will give in the problem. For example, if I had considered finite length conductor. Okay, what you are having the expression. So what they will ask, just to find the total magnetic field for a given conductor with a finite length. What they will give you simply they will give you the length. Is that right? Length of the conductor they will give you, and moreover they will give the what is the angles here. Is that right? They may give the for example they may give the other things, but just you need to know that the sign. If they give you sine 90 means it will use the infinite length. Apart from that the 90-degree they will give you a 45, or else they may give you a 0, or else they may give the other angles. But you need to know that the trigonometry functions what will be the value. By knowing that one you will get it very easily. Okay, so simply the thing is, or what you are having expression b is equals to mu naught by 4 pi you are having. You must have to know the constant value of mu naught, that is the permeability of in the free space mu naught value, and you must have to know the pi value. So now you got the mu naught by 4 pi value. Okay, into what we are having here, sine pi 1 and pi 2 they will give you. Okay, is that right? And moreover they will give the current also. Is that right? And moreover they will give the uh, what will be the radius here, how much they will give that one. So by knowing parameters, by using the knowing parameters, just you need to find the unknowing parameter, which is the total magnetic field. Okay, so in the finally just we look at the problems also, don't bother about that one. Okay, and now this is a very simple method to of how you are going to resolve the problems which is related with these concepts. Okay, understood all of you. But you need to know that you are able to specify the cases whether the length of the conductor is whether it is a finite or whether it will be the infinite simply. And remember that sometimes the case is what, ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ simply he is not able to mention the infinite length ನ mention ಮಾಡೋದಿಲ್ಲ. At that moment what he have to know that if he had given the angle as pi 1 and pi 2 as a 90-degree means simply just you need to think yourselves, this the given condition of this length of this conductor is infinite. Simply you can use that formula. Simply what we are having, mu naught by 4 pi into 2 I by r, that's it. Just you need to substitute I and r, and from that you will get the total magnetic field. It's a very simple thing. Okay, simply the very important thing is what, just you need to understand the concept. Okay, and you need to understand the uh, which case he had asked, and what are the knowing things he had given in the problem, and what we have to find out. It's a very simple trick how you are going to resolve the problems. Okay, so hope that this is what the all about the today's concept regarding this extended part of this Biot-Savart's law. Okay, that is what the magnetic field current carrying in the straight conductor at the point p. Okay, so this is what the uh, main important concepts we have what we have discussed in this class, and this is what the end of today's class. If you are having any queries regarding this derivation or else this explanation towards this concept, You can ask me or else you can put it in the chat box. You can unmute your radio. ನಿಮ್ಗೆ ಏನಾದರೂ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದ್ರೆ ನೀವು ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಕೇಳ್ರಿ, ಇಲ್ಲ ಅಂತಂದ್ರೆ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ನೀವು ಜಸ್ಟ್ ಪುಟ್ ದ ಕ್ವೆಶನ್. Okay, so hope that you don't have any questions, right? Okay, so that's it. So hope that and another thing is what
ಸರ್
Shatam.
ಕನ್ನಡದಲ್ಲಿ ಹೇಳಿ ಸರ್.
Okay. Okay. So one second. And another thing, initially there is a problem with the network also. Okay, sorry for that. So that's okay. Okay, so in the next class ನಲ್ಲಿ ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ we will discuss with the next concept which is related with the previous concepts only. ಈ ಕಾನ್ಸೆಪ್ಟ್ ಆಮೇಲೆ previous concept ನ ಇಟ್ಕೊಂಡು ಮುಂದಿನ ಕಾನ್ಸೆಪ್ಟ್ ನ we will discuss that one. Okay, so if you are having doubts means ನೀವು chat box ನಲ್ಲಾದ್ರೂ ಹಾಕ್ರಿ, ಇಲ್ಲ ಅಂತಂದ್ರೆ you can unmute your audio. Okay. Okay. Okay.
ಮುಂದಿನ ಸಲ ಸ್ವಲ್ಪ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಿ ಸರ್.
ಓಕೆ. ಆ ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ಬೇಕಾ? ಆಯ್ತು, ಸರಿ ಹೇಳ್ತೀನಿ. ಆ ಮತ್ತೇನಾದರೂ ಪ್ರಾಬ್ಲಮ್ಸ್? ಎನಿ ಪ್ರಾಬ್ಲಮ್ಸ್?
ನೋಟ್ಸ್ ನಾವು ಸ್ವಲ್ಪ ಗ್ರೂಪ್ಗೆ ಹಾಕ್ಬಿಡಿ ಸರ್.
Okay, notes. Okay. So simply the thing is what these are the PPT slides ಇದೆ ಇದು. Okay. So I think so it's not much. There is no any explanation. Explanation ನಾನು ಓವರಲ್ಲಿ ಹೇಳ್ತೀನಲ್ಲ, so that ನೋಡೋಣ. Just I look at to the reference books. Reference books ನಲ್ಲಿ ನೋಡಿ ನಿಮಗೆ ನಾನು ಸೆಂಡ್ ಮಾಡ್ತೇನೆ. Okay. These are the PPTs. It's not much worthy to study here because the explanation much more ಇರೋದಿಲ್ಲ. Okay. ಸೊ ನಾನು ಇಲ್ಲಿ ಹೇಳೋದು ಓರಲಿ ಹೇಳ್ತಿರ್ತೇನೆ. ಓಕೆ, ದಟ್ ಸಿಂಪ್ಲಿ ಜಸ್ಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಓನ್ಲಿ. ಮ್ಯಾಥಮೆಟಿಕಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ಗೆ ಮಾತ್ರ ನಾನು ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಬಟ್ ಸಮ್ ಐ ವಿಲ್ ಟ್ರೈ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು. You may leave the class.